really wanted to have with us for the last years. Can you close the door? Yes, to that. Are in this room for brain trust or a conversation they've been having. So they actually went to school together. I'm sorry for ruining this for you and saying this myself, but they went to school together, and a lot, I think, of their art practice was, I hope, developed through conversations that you had, arguments and fights they had during this year. And you are going to watch all of this live. So you have a great, special opportunity to witness more than just an artist talk, but a real match between friends and, how do you say, arguers? Like debate partners.
Hopefully we'll debate.
We've come to agree too much over the years.
Yeah, we'll have to do something about that.
So I think Heather, I don't know how many of you have been in the workshop. I think people are new. So Heather had a workshop here yesterday, which was amazing. And I think you will get a bit of it. But I think it will be a wonderful opportunity. And I just want to say that you should check afterwards her new work. It's on the first floor of the exhibition. And a bit of housekeeping before I leave you. WC is over there, you've seen. There's also some kitchenette. If somebody is really, I don't know if there's glasses there yet. Yeah. Somebody is really, really thirsty. Just enjoy it. There's a lot to see tonight. Take a program afterwards on the left if you haven't. And that's it. And I wish you a wonderful night. And thank you guys for being here.
Thank you very much, Leo. So yeah, thank you for giving us this opportunity to debate again. So I'll just introduce, Heather and I were talking about how we want to do this, and Heather's work has been phenomenal and very kind of spread around a lot of topics, and we decided to choose a certain vector for her work that kind of has repeated in many ways and repeats in the new work that she's presenting here in the exhibition. Maybe one of her more iconic work is Stranger Visions that you see on the screen right now, and she'll be talking about that as well. But I actually asked Heather to start with a work that she doesn't necessarily always talk about in talks like this, which was her thesis project at the IDP at NYU when we studied together. We graduated in 2007, and we will try to start from there. Heather will talk about a couple of projects. I'll interrupt her as she speaks because I'm Israeli. And then we'll have a conversation. We've been so eager to have this conversation that at some point we stopped ourselves, so we won't spoil everything for this evening. So let's get started.
Sounds good. Okay. I don't have this situated. Can you hear me okay from the back? Not so much.
I can help them, right?
I have to lean in.
Half autistic writer, half a tech guy.
That's the way you roll.
You might be able to.
Okay. So I think I want to talk about this work that Mushon mentioned, which is called Spurious Memories, that I worked on in the grad program that we both went to in New York. And to get there, I just want to start by saying, so the work that you're looking at here, Stranger Visions, this is a work where I collected forensic artifacts that I found on the streets of New York, so things like cigarette butts and chewed up gum and hairs and bits of fingernails. And I brought those to the world's first community biology lab that had just opened up down the street in Brooklyn called GenSpace, extracted DNA from them, analyzed the DNA, and used that to generate computationally generated portraits showing a possible face of the person who left it behind. And so what you see here are these 3D printed generative faces derived from these forensic artifacts. And guess we're going to have to just jump through all the slides here. Here's a quick view of all of that. And here we go back in time. So how is it that I came to think of generating these faces like this, working with the forensics, and putting that together with this kind of generative modeling of the face? I wouldn't have known how to generate faces if I hadn't spent quite a bit of time in the years prior working on machine learning and facial recognition technology. So this is an image of a pattern that's used to train a type of neural network that's called a Hopfield neural network. This is something that I got excited about in, I guess, 2006 when I started working on this project, Spurious Memories. And what I was excited about was that these neural networks have this property where when you store patterns like you see on the left in the network, it automatically also remembers things that it's never seen before. So it remembers the intersections and reverses of the patterns that you've entered into it. And I thought that this was really interesting and really exciting because it felt to me a bit like creativity, a bit like what we do as humans when we're being creative. We kind of look at precedent of things that came before and think about how they relate and interact and come up with new ideas based on previous experience. And so I went into my thesis project trying to explore this concept of machine creativity. And I used a data set that was conveniently at hand, and that was the faces of our colleagues. So we have many more than this. This is a small subset of the kind of batch of the faces. So we had, I think, 200 students in the program with us. And all of them had their faces photographed when they entered as students. And I was able to obtain those without anyone's permission, I might add. I mean, now that we think of these things years later. But the department just gave me all of the pictures of the faces to use as a data set. And then I used these to basically train this neural network. And so it was a neural network that would normally be used for doing facial recognition. So you put in these pictures of people's faces, and then you could use that to identify versions of that face that might be noisy or distorted in some way. Worked okay. So this is kind of, this is 15 years ago, basically. So the facial recognition technology was not as advanced as it is now. So it was much more kind of basic, the algorithms that were available at that time. But it worked okay. And so I was working with these faces and thinking about creativity, and I realized that when you store these faces in the neural network, what you get also is a kind of landscape of possible faces that exist in between. So in addition to knowing these faces and knowing these pictures of people, the network also knows all of these fantasies, all of these imaginary faces that don't actually exist, that are, in this case, kind of the intersection in inverses, like the patterns that you saw of the faces that it's learned. And so the output of this is this kind of strange, what I thought of at the time as the kind of daydream of a neural network. These fantasy faces that existed in between the real faces that the network had learned. And when I started working on this project, I was very much, really genuinely interested in the question of whether a machine could be creative. Much like there's a whole philosophical discourse going back to the 1950s of whether artificial intelligence can exist, whether a computer can be intelligent. I thought it was very interesting to ponder if a computer could also be creative. And Mushon and I had many conversations about this at ITP. And I don't know, maybe you want to
I'm just
comment on that. What I'll mention also is, I worked with faces because they were at hand. And because, of course, a face is always compelling, it always draws you in. And as I started putting together these pictures of faces with these algorithms that I found so interesting in and of themselves, I've been for many years since I was an undergraduate really interested in artificial intelligence, machine learning algorithms, and I just thought that they were interesting as this kind of poetic and visual framing devices. And so I started putting that together with the faces, and then what became apparent to me through conversations in school, including with Mushon, was the incredible political impact of that. So I think up until that time, I considered myself an activist and an artist, but I didn't really put the two things together much, or ever, actually, I would say. And when I worked on this project, and after having our conversations and so on, I really started thinking more politically about my art practice as well. Because what became immediately clear to me, let's say around this time, 2007, was that the primary use case of this kind of tool would be for surveillance.
So, around that time, we were just speaking about that around 2005, 2007, the hot thing was Web 2.0. So it was like social media was like going to democratize everything, and it's a digital revolution, and we're very excited about that.
I thought it was totally boring.
I was super excited. And one of our professors, I remember something that he said about profile pictures. So, creation. Was saying that a face is the most information that you can stick inside a 40 by 40 pixel image. And I was like, I was really struck by this idea, because why? Like technically, like if you ask a computer if that would be the most information you can stick inside the image, probably the answer would be no. But for us as humans, there's something so ingrained with our pattern recognition. Like if there's one thing that we're so trained in, is people's faces. So the idea of sticking a face next to anything has become the icon of social media, right? So if you like, I'm an interaction designer, and when we're trying to say this is something that was made by a certain person, just by sticking an image next to it, it creates that, and that imagery becomes so full of information. But I think we'll continue the conversation to ask, like, when we're talking about this being full of information, what do we actually mean? Like, what do we see in the image?
And how does what we see in the image relate to the algorithms of what the computer sees? I want to mention that at this time, so this was a moment also when cities were becoming linked with surveillance cameras. So around this time, London and New York both became kind of totally filled with cameras, and suddenly there were like thousands of cameras on the streets that hadn't been there before. And that immediately raises the question of who's going to be looking at all of these camera feeds. And the answer, of course, points towards automation and towards facial recognition as a source of analysis for this. And so that became a vector of kind of inquiry that I became interested in progressively after this time. And in the years in between this project and working on strange provisions, I did a number of projects kind of looking at surveillance technologies in different ways, and also thinking about data profiles and kind of the corporate collection of data, particularly thinking about Google, which is something that we talked about. Also, I would say a lot in grad school, this kind of growth of the data market, commodification and exploitation of our data, which has now become pretty well known. It's interesting to see how much these critiques that were still pretty nascent, but this in, let's say, 2005, 2007, have become really a part of mainstream discourse and even regulation. We're thinking of like GDPR in Europe. So that's probably a good thing that came out of that. And that led eventually to this moment where I was in late 2011 sitting in a therapy session in New York. And I've been working with these machine learning algorithms and thinking about surveillance. And also, I'm someone who always loves the detective story, so I'm a Sherlock Holmes fan. And it was also a time period where shows like CSI were very popular. And I was sitting in this therapy session, and I noticed that there was this print across from me on the wall. And the glass that was covering this print was cracked. And there was this hair that was stuck in the crack of the glass. And I sat there for the hour of the session, just staring at this hair. It was really like a long brown hair stuck, tangling out of the glass, really right up above the couch. And I started imagining this person with long dark hair, sitting on the therapeutic couch and leaning back and getting it caught. And just started thinking, what could I learn about someone from a hair? What if I took this hair and extracted the DNA and analyzed it? What could I find out about that person? And that launched me into this project that became Strange Visions, that brought me to the lab that I mentioned earlier, GenSpace, and led me to put together the research that I've been doing in machine learning and looking at facial recognition models and putting that together. And so I started collecting these artifacts around New York City, so cigarette butts and gum and hair, brought them to the lab, and so here's the connection point really between thinking of the earlier project Stranger Visions and how that came into the earlier project Spurious Memories and how that came into Stranger Visions. So this is what's called a morphable model. It's a mathematical model that was developed at the University of Basel, Switzerland, and it is used. So the purpose of this model is 3D facial recognition. So they developed this for basically the purpose of, imagine that you have a database of pictures of people that are taken from the front, and then you have a surveillance camera on the street, and it catches a picture of the person from the side. So the purpose of this kind of 3D facial recognition system is to project that image from the side back to a full face, back to a frontal facial image, so that you can match that up to the database. And practically what that meant is that they had taken this kind of data set of 3D scans of people's faces, turned it into a mathematical model that could be parameterized or kind of pushed in different directions that they identified. So directions that you see here, like male or female, or heavy or light, or young or old. And so when I saw this, I realized that this was a tool that I could connect up with the DNA profiling that I was thinking of to generate possible faces based on a profile, based on a genetic profile. And so I only kind of knew to do that because I've spent all of this time kind of digging into neural networks and thinking about these surveillance technologies for the years prior. And just to give you a sense of that, so this is just a morphing animation that shows you potential faces that all come from the same DNA source. In this case, it's the DNA data from James Watson, so one of this kind of infamous figure in biology, who's one of the people who first published the concept of DNA, the double helix, with data that was stolen from Rosalind Franklin. Probably many of you are familiar with this story. And he is also the first person who made his genome public. And so his data was the first kind of open source genome data. So these are a bunch of different faces, basically, that could be James Watson based on his DNA. And so when I worked on Stranger Visions, I would take the genetic profile and then generate like 5 or 7 different possible faces based on that profile. And then I would subjectively, artistically choose a face that was meaningful to me. So I'd look at it and say, that face makes me feel something, or that face reminds me of someone. And then choose that face to represent that profile, output that as a 3D file, and then 3D print that in full color.
So that's a good point to interject. I think there's, on one hand, when you're saying, and then I chose subjectively, it's like so obvious to us that's how we work. But then this is the thing that machines can do, right? they can say, oh, I like this face, or there's something about this face that I relate to. And I really love that you showed that morphing animation, because we've seen a face morph across a pretty wide range of faces to the degree that you would ask yourself, what's the point, right? Like, can you really tie between this kind of scientific forensic process of identification, which we can maybe talk about its history a bit, to this projection of a face, and then I think that's where your practice as an artist, as taking this as kind of a speculation of a face, makes a lot of sense. But at the same time, and you just showed me, maybe we can jump to the fact that this is not only an artistic practice, right?
Exactly. So I started this in 2012. Was working on it through until 2013, and at that time I was mostly interested in showing the vulnerabilities of the body. So I'd have this kind of revelation that we're shedding our genetic information all the time, that can be mined by anyone. Anyone can come along and pick up my hair and find out all kinds of things about me. And I was really struck just that it was so little discussed. And it was increasingly cheap and fast and easy to analyze genetic data. So why weren't we talking about it? Why weren't we talking about that as a kind of data risk in the way that we were talking about other forms of privacy and surveillance risks? It's still true, by the way.
But if we're looking at the range that we've seen, I think one thing that we can see, especially from the morphing, is that you can't really tell how I look.
So what I want to say is that in this moment, what I wanted to do, so why I put the singular face to the sample, is that I wanted people to walk in and think, oh, that could be me. That could be my DNA, that could be my face that she puts on the wall, and to have this kind of visceral experience of the face. And for that purpose, it had to be singular. And so when I started working on the project, I thought, should I have multiple faces or one face? And I decided to go with one face because I thought it would have a bigger impact in bringing across these kind of vulnerabilities of the body, thinking about the surveillance risk of it.
So let me push back at that a bit, because one of the things that I'm asking myself about this part of the work is that coming out of Stranger Visions, seeing that proposition, like here's the cigarette butt, here's the person's face, there might be an aspect of that of like, you mentioned the term paranoia. Like, isn't the work in a way propagating paranoia? That when we're seeing the behind the scenes that you're showing us now, should not necessarily be experienced as such. And I think if you tie in the non-artistic similar practice, we can see that there's maybe you can show
exactly. So what happened then? So I'll lead into that just to say. So I was focusing on thinking of the surveillance risks, and then also thinking I want to show that I've kind of found this emerging field that's called DNA phenotyping. So there was kind of preliminary scientific publications around this effort to generate faces from DNA, not fully as faces, but more like looking at eye color, looking at hair color, looking at ancestry from forensic samples. And so I wanted to show that this was a practice that was emerging, that would be coming basically around the corner. And so that was 2012, 2013. Here are some of the faces. And what I didn't expect is that practice that I thought would be probably like 5 years off would come much faster than I expected. So this is an actual clipping from a newspaper. This is a so-called DNA mugshot made by a company called Parabon Nanolabs. So in 2014, so just a year after I worked on Stranger Visions, this company launched a product or a service that they called DNA Snapshot to police around the United States. And they claim to create these mugshots from found DNA from crime scenes. And this was literally printed in a newspaper. It's a clipping that a friend's mother sent to me from her local newspaper in Massachusetts in the US. And if you take a look at this profile, I don't know how well you can see the picture, but what you can see is that it says sex male, age unknown, body mass unknown, ancestry European. And maybe there's some freckles. The guy has brown hair and brown eyes. And so it's really not a very compelling data set for a portrait, I mean, especially coming from the police. So they're not really claiming much here. They're not claiming much knowledge. They're basically, what they're doing is putting together an image of a stereotype and then putting that out as police evidence, essentially.
So is it, like when you're working on Stranger Visions, are you thinking like, okay, right now the faces can move quite a lot, but maybe like give it a few years and it would be super precise?
When I started working on Stranger Visions, I didn't know how much I could find out about people from their DNA. So I went into it actually thinking that I could probably learn a lot more. And what I found in doing the research over the year of working on the project is that it was much, much more limited than I ever expected. So I thought going into it, okay, I'll extract the DNA, and then, I mean, DNA, it's the code of life, right? It makes us who we are. And that should be really pretty compelling data to tell me things about a person. And then over the course of the year of doing my research, what I learned is that it was really, that there was so much we didn't know, that there was really so much debate around how much we could ever know, how much genetics indeed shapes who we are. I mean, we all know this kind of tired, like, nature versus nurture thing, but really how deep that goes. I mean, to the point that most things that we think of as being important about who we are, about our identity, and even about how we look, comes from a very complex interaction of genes and environment. And so what I ended up coming out with is actually thinking, oh, it's much, much more limited than I ever would have guessed. And it may be that way forever. So while there is some truth to saying that that biotechnology advances and that genetic studies advance, I think that it's kind of diminishing returns. I don't think we're going to come much closer to understanding the actual way that genes work, the way that genes, or the kind of constellation. So I think the point is that it's not just the genes. So it's the genes, but it's also the context of the cell. It's much more going on kind of on the biological side, and then how that interacts with the environment. And I think we probably will never know all of those details.
So I think that's a good moment to time and the history of physiognomy and the idea of like for many years or centuries. Starting at the beginning of the 19th century, there was this idea that if we know the biology, if we analyze how someone looks physically, we would know what kind of a person are they. And scientists have been playing with this idea again and again, realizing that it doesn't really work that way, and continuing this research. And that's a good, also a good point to kind of separate between two, I would say, motivations. Like one motivation would be identification, and the other one would be analysis. what do I mean by that? In the late 1900s, the police in France was collecting a lot of photography. They started using photography as a part of their when they arrested people. And then when they arrested, every time they arrested someone, they wanted to know, do we know them from somewhere? Remember, they didn't have IDs yet. And the city was really changing. Paris was changing. In the past, you knew everybody around you, but the city, grew, and people came from the villages, and all of a sudden you had like people that nobody knew. So nobody knew that this is not Francois, this is Jacques, or whatever. So, the guy would be arrested, and he would say, "My name is Francois," and he'd never seen me before. And they would look through the pictures, and they had no way of making sense of these pictures. They had a picture of Jacques somewhere, but there was no way of indexing them. So this police officer, Alphonse Bertillon, created an indexing system. He basically said, okay, I'm going to separate all of the noses that look like this, all of the eyes that look like that, all of the mouth that look like this, all of the heads that have this shape, and he created an index system. And every time they would arrest someone, he would start quantifying the body. He would also check, lengths and stuff. And he created a whole system of understanding the body through measurements. And then they were able to say, oh, actually, we found the picture. He also invented the Mugshot, the way that we photograph arrests until today. His whole system spread all around the Western world and was replaced 8 years after with a fingerprint that was obviously much more precise. But the whole motivation of Bertillon was identification, right? While what happened next with his system is that it was used for analysis. One of his greatest fans was Gallatin, Francis Gallatin, the founder of the eugenics movement, and he was a cousin of Darwin, and he saw the evolution theory of evolution as not as an analysis of nature, but as a prescription for where should nature go. So he would say, we actually need to help nature to become more perfect. So he took the system that Bertillon developed and said, okay, this is how a perfect person should look like. And they actually made sure that, if you had a defect, if you had like a slit lip or something like that, you wouldn't be able to recreate it, because that would not be helping nature. That's where the eugenics went to. Obviously, the Nazis were into that as well. All of that has become kind of this transition from identification to analysis and then to scaling has been, these are different motivations, but when we have them within quantification, it's like there's no way around it, right?
Exactly, and I just want to mention also that these are kind of the deep roots of the tools and technologies and sciences that are still considered kind of cutting edge today. So if you look at eugenics, for example, so the concept of eugenics after World War II went through this kind of identity crisis, you could call it, and became rebranded genetics. So it literally was so I think when we think of eugenics coming out of the 19th century into the early 20th century, it's easy for us to look back at that now and say, oh, that's just pseudoscience. Same with physiognomy and the rest. But what we have to remember is that in that moment in time, that was good science. That was the best science that there was. And people were fully on board with it. And that then really just became folded into, literally rebranded as genetics, as genetic science after World War II. And same with physiognomy. I mean, so this idea that you can take measurements of the face and use that to kind of tell things about a person, so that that basic impulse of quantifying and classifying people based on facial measurements continues to this day through fields like machine learning. So looking at the classification of faces and how that gets folded into data sets that get used for the facial recognition technologies that we were talking about at the beginning.
And that is like the good science of today.
Exactly. And Galton also invented the field of statistics that is the substrate on which all of these practices unfold. So without statistics, without Galton, without eugenics, you wouldn't have any of the AI, machine learning kinds of tools that we have today. We wouldn't have Google.
So you have kind of the dark history of statistics and genetics and machine learning. And as I said, we're looking at that as the dark past. But then we're looking at things like that. And this is the dark
present.
And now I want to ask you, like, what is our role, if we can even say that, if we have a slightly more critical analysis of what these technologies, what can these technologies do and what they can't do? Like, what is our role in communicating that to the public, if at all?
So I think that we do have power as artists, as designers, in inviting people to think about things that they wouldn't think about otherwise. And that can be used to really advocate for regulation, for example. There's kind of several fields on which I think that we can have an impact. And one is kind of directly influencing policymakers, and another is influencing social norms. So influencing how we think about things like our data profiles, like our use of social media, and like thinking about our DNA data, thinking about our cells, thinking about our kind of biomedical profiles as continuous with that. I think that there's examples that we can think of where art has really informed public discourse around it, and that has actually ended up resulting in regulation that is significant. So one example is thinking about genetic privacy in the context of the United States. So there was a lot of art that came out at the time of the completion of the Human Genome Project, and there was a film also called Gattaca, maybe some of you have seen it, from I think 1997. And this film shows this kind of dystopian future that could come through is really a kind of neo-eugenics via genomics and via really enforced breeding technologies in the population. So it's this kind of scenario where no one has kind of natural babies anymore, and everyone is supposed to be genetically born in a predetermined way.
So I think two opposing strategies here. One is the more paranoia-inducing storytelling, whether it's the dystopia of Gattaca or in a way Stranger Visions.
Definitely.
And the other one is a more skeptical perspective on the technology itself, because even in the days of physiognomy and the whole strain of evolutionary racism or scientific racism, what was dangerous was not the science. What was dangerous was the fact that people believed it was true. And I'm asking myself, like, should we say, this is scary, look, this is super scary, let's regulate it fast? Or should we say, this is pretending to be something that it's not, and let's stop giving it the power that it demands?
So I feel actually that both are true. So the kind of end of the story about Gattaca is that there was legislation passed in the United States called the Genetic Information Non-Discrimination Act. And that makes it illegal for your employer or for a health insurance company to discriminate against you on the basis of your genetic data. And that's a big deal. I mean, so there was a lot of kind of paranoia-inducing culture coming out at that moment in time. And I think in this, at least one instance, you could say that that had actually an important impact. So I'm really glad that we have that piece of legislation passed in the US. We talked about that in the workshop a bit yesterday, so I know that it is not passed here. I mean, you don't have a similar legislation here in Israel. So if you have your genetics analyzed here, it can be used against you by health insurance, for example. So that's just, I mean, something to think about. But as I was thinking about these topics, and I mean, so after this happened in 2014, I started thinking that I needed to really retool my approach, and that it wasn't enough to call attention to this problem, that it wasn't enough to show people that we had this risk of shedding our genetic information that could be used against us. There was this phenotyping coming around the bend, but it was here now. And so I wanted to instead put my efforts towards critiquing that technology and showing its limitations. So just as Mushon was saying. And I started thinking, well, how can I, in a way that's meaningful, invite people into seeing that you aren't as simple as just your DNA data, that this kind of concept of genetic determinism, that would be an overly reductionist way of seeing who you are. And so I started writing and talking about these issues, and then a kind of interesting thing fell in my lap, and that was a collaboration with the US whistleblower Chelsea Manning. So Chelsea Manning became known for information that she made public exposing the enormous amount of civilian deaths and torture in the Afghanistan and Iraq wars. And so she was arrested and then sentenced as Private Bradley Manning. And after her sentencing, she announced her gender transition and became Chelsea Manning. But this was also the moment when she was put into a military prison and hidden from view. So after that time, no one was allowed to visit her, no one was allowed to ever see, to photograph her or to see an image of her after that point. So you could say in a way that no one had actually seen Chelsea Manning because she had had her image suppressed since she was incarcerated, or since she was sentenced. And so I was contacted and asked if I would create a DNA portrait of her so that basically she would send her genetic material to me from the prison, and if I would then make a DNA portrait of her to kind of sneak her image out to the public. And so in the midst of thinking about these things, so it was really exactly at this time period, I got this request from Chelsea and from Paper Magazine. So Paper Magazine was doing an interview with her through the mail. And I realized that this was a kind of first opportunity to show some of the limitations of the phenotyping tool by bringing attention to the reductionism around genetic sex. And so we had kind of conversations about how to handle that, because Chelsea's transgender, how do we look, what happens with the profiling of genetic sex in this portrait. And we decided ultimately to present two portraits to represent Chelsea. So here's her cheek swabs that she sent to me out of the prison. And here are the two portraits that we originally came up with and that I generated to represent her in 2015. And so what you can see on the left is this supposedly gender-neutral portrait or androgynous portrait, and on the right, the parameterized female version of that portrait. And so I hoped that by putting these side by side, it would make you question a bit about DNA profiling and the accuracy of that. and also make you think about what it even means to have a kind of computational model of something like gender or sex. What would it mean to have a female face? How could you even think of computationally representing something like that? And the absurdity of these models that have this kind of slider, male to female, and how really reductionist that is. So this was the first project that we worked on together, and kind of to make a long story short, I'll just say that we continued to keep in touch, and together we made a comic book for her clemency campaign that's called Suppressed Images. You can take a look at this online, suppressedimages.net. And this tells the story of our collaboration. It talks a bit about DNA phenotyping, some of the problems with DNA phenotyping. And it ends with this, with what was a speculative wish. So at the last frame of the comic book, we imagine that President Obama would commute Chelsea's sentence, and then she's freed and is able to come finally in person for the first time to see her portraits on exhibition. And the amazing thing that happened was we published this on the morning of January 17th, and that afternoon Obama actually commuted her sentence. So it was really this incredible moment of feeling like you had this kind of magical power to encant the future. And of course it wasn't that simple, but I do hope that sort of the work that we put into this, together with a lot of efforts from really dedicated activists, got her released. And then here she is actually seeing her portraits in person for the first time in an exhibition that we had to celebrate her release from prison at Friedman Gallery in New York. And so on the occasion of having this exhibition, basically we were given like 1,000 square foot space, and I had only 2 portraits to put in that space. And so we realized this is a great opportunity to scale the project up. So imagine, what could you do next? What comes after 2 portraits? And I wanted to use that as an opportunity to show how many different interpretations of the data are possible. And so what we have, what we put on display is a new piece that we call Probably Chelsea. It's a collaboration between Chelsea and I. And it shows 30 different interpretations of the same DNA data. So it's a bit like the morphing video that I showed you in the beginning of James Watson's DNA, but these are 30 portraits of possible or probable Chelseas that come from her DNA. So it's a kind of illustration of this possibility space that is really meant to open up and invite people into critiquing these ideas of genetic determinism, and also through this form. So this was the first time that I was taking the portraits off the wall and having them kind of stand at human height in the center of the room. And what I hoped is that this would evoke this feeling of a crowd and the kind of mass movement that stood with Chelsea and that advocated for her release from prison.
So while the 2 works are obviously continuing each other, they're basically opposing each other.
Mm-hmm. Yeah, exactly. So I like to think that I build on my previous work by reflecting on it and subjecting it to critique also, or building on it in ways that can enrich and make you think about it differently.
And how did the public respond to that, to these 2 basically opposed propositions?
I don't think that most people give it that much thought. I think people take things one at a time. So I haven't had a kind of retrospective where I have all of the work in the museum side by side. So people would come to walk by the gallery, and basically said this was a street level gallery with a big window onto the street in Soho, and people would just walk by and be like, sort of get drawn in by the spectacle of it, let's say. And that you see this like suspended crowd of faces, and then come in and be drawn into the faces, and then learn what it was, and then have this kind of like, whoa, what? What does that mean? And get drawn into that critique. So I'm really excited to say that this piece was acquired by the Exploratorium in San Francisco, which is a science museum. And I think that that's really great. And so basically when you walk into the biology exhibit in this science museum, it's a kids' science museum, the first thing you see are the 30 portraits of Chelsea, that greet you and invite you in to think about DNA and think about biology and genetics in a more complex way.
In general, I think, I know there are a lot of media artists in the audience. I think science museums are super important. Like, we should work with science museums. It's a part of the kind of stage that that media art gets in the gallery, in like the art world gallery, is it's an important but a very different perspective to speaking about the topics that we care about. But then the opportunity to bring to say, okay, here's a different perspective about science, and here's a different way of speaking about science, and breaking from the very positivist approach to be a scientist because science is the answer for everything, and if a scientist said so, then it must be right, because physiognomy was science, and machine learning is science. It is science, but it has to be read in a cultural context, in a historical context, and I think that the opportunities to work within this context and actually be a part of this, maybe sometimes kind of the word that artists are so afraid of, didactic context, is a privilege and an opportunity that media art gets sometimes more than other forms of art.
Exactly. I mean, I just find it totally exciting that hundreds of kids are going to come into this museum every day, and this will be their introduction to thinking about genetics. We'll be immediately thinking of how complex it is, and how multiple it is, and how all data is subject to multiple interpretations, and all data is a way of telling a story, right? And that there are at least 30 different stories, and actually, infinitely more stories that you can tell about Chelsea from her DNA data. And so I think it's really a great opportunity. And what I try to do is to be able to create work that can live in many different contexts, so that it can sit in the gallery and have kind of one context, one world of interpretation, and then it can also sit in the Science Museum. It can also be used for policy conversations and interactions like that as well.
Maybe we can, we probably don't have much time left.
We have no idea.
We have 3 minutes. That's a great opportunity.
Sorry, we just talked and talked.
To open into the audience, so we'll probably have time for one question.
No questions?
There's a very good question waiting in the audience. I know it's here. It is. Yes.
Maybe it's a more technical question. I was curious if you can explain a bit more how you go from DNA to face, like technically.
Sure. Yes. Okay. So if we just go back to the facial model, wait, where is it here? So I realized that I could create a genetic profile from the DNA, so I could read things out a bit like this. So I could look at genetic sex, for example. Just take that as one example, even though we've just been deconstructing it since it's here. So I realized I could look at a DNA sample and read something like genetic sex, and then I could take that and feed it into a 3D model like this and output a face based on that.
How many parameters, like how many things like sex?
So I had a kind of master list of about 40 different traits that I was interested in, that I pulled from kind of emerging research, so some established research, some emerging research. A lot of it I was pulling from the site 23andMe, which is a personal genetic profiling service. And so 23andMe would have this like long list of traits, so things like eye color and hair color, and then of course things also like skin color, things like ancestry, things that are much more contentious. I mean, that's a whole nother conversation that we have that ties directly in with these concepts of criminal profiling, physiognomy, eugenics. And so I've also written about DNA phenotyping as racial profiling and stereotyping. And if you're interested in that, I would refer you to my article, Sci-Fi Crime Drama with a Strong Black Lead. It goes totally into exactly this history and into how, how DNA becomes this new form of stereotyping.